The cortex is responsible for the so-called higher functions, such as memory, intelligence, judgment, reasoning, and language, as well as speech, sight, and voluntary movement. Although the two hemispheres are almost identical, in the majority of people, the left hemisphere is dominant. Right-handedness usually results. A few right-handed people have a dominant right hemisphere. Dominance is inherited. The dominant hemisphere is important for mathematical, analytical, and verbal skills, such as the understanding of spoken and written language. The non-dominant for non-verbal skills, like recognition of faces and music, and the understanding of time and space. The cerebral cortex contains over 10 billion neurons. Over 2/3 are pyramidal. Each has a thick apical dendrite, which extends towards the surface, and basal dendrites, which spread outwards into the cortical matrix. The dendrites are covered by spines, the site of up to 4,000 synapses with other neurons. The axon of each pyramidal cell projects from the base of the cell body. Confined to the cortex, stellate or granular cells form much of the remaining third. Smaller than pyramidal cells and round, they have a single short axon and multiple branching dendrites. The various types are found in all cortical layers except the most superficial. Typically, the cortex has 6 layers: plexiform, external granular, pyramidal, internal granular, ganglionic, and multiform. In layers 4 and 5, horizontal fibers, usually terminal and collateral branches of afferent fibers, aggregate to form 2 bands, the outer and inner bands of Baillet, respectively. Variations in this classical 6-layered pattern between different regions led Brodmann, earlier this century, to distinguish no less than 52 different areas. Some are closely associated with specific functions. Brodmann Area 8 with movement, and areas 44 and 45 with speech, for example. A simpler system which recognizes only 5 types of cortex also correlates with function. Agranular cortex is found in areas concerned with movement, and granular cortex in areas concerned with sensation and hearing. Both types have only 5 layers. Agranular cortex has no granular layers, and granular cortex no plexiform layers. Frontal cortex, parietal cortex, and polar cortex have 6 layers. 2/3 of the total cortical area cannot be seen on the surface of the hemisphere. The cortex is folded into a series of irregular eminences called gyri, separated by fissures or sulci, which permit an increase in area without a corresponding increase in brain volume. Thickness varies from 1 millimeter at the poles to almost 5 in motor areas. The lateral sulcus, the central sulcus, and a line drawn from the preoccipital notch to the parieto-occipital sulcus divide the surface of each hemisphere into lobes. The lobes take their names from the bones which overlie them: the frontal, the temporal, the parietal, and the occipital lobes. A 5th area of cortex, the insula, is buried beneath the lips of the lateral sulcus. At the ends of each hemisphere are the frontal and occipital poles. The temporal pole lies at the anterior end of the temporal lobe. The lateral sulcus divides the inferior surface into 2 parts. It branches into 3 rami: anterior, ascending, and posterior. The central sulcus separates the precentral gyrus, associated with movement, from the postcentral gyrus, associated with sensation. These areas differ not only in function, but also in microscopic structure. Hence, the central sulcus is termed a limiting sulcus. Medially, the area around its origin is called the paracentral lobule.